Hello, friends. Welcome to Eastern Academy, and we are discussing about microprocessor as a part of embedded system programming. And today is session 7. Okay, and we are going to discuss about output. That's just a very, very important topic. Normally, people should know that how the microprocessor is controlling various things. When it is having only address and data. Okay, so never forget the rule of thumb. The rule of thumb is that all microprocessors in the world has address lines, write, read, data. That's it. Then you give a power supply. You give a power supply and you give a reset signal and you give a clock. That's all microprocessors. Okay, this may vary. The address could vary from initially start with 12, then 16, 20, 24, 32, 40, 48, 44, 48, goes like that. That means that I can go for 2 power 12 to 2 power 48. Such a big memory I can access. Okay. 1 minute. Okay, so right now in our discussion, we are taking 6. And data could be 8 or 16 or 32 or 64. Okay, so that's what things can vary. How many? This means that 6 wires. This means 8 wires. That means 8 pins. That is actually on IC, so many pins. These are all physical devices. Please understand, this is all physical. Now, what we have done is, let us assume that I have a ROM. I have a RAM. ROM for my code, that is software. RAM for my data, that is variables. My variables are stored here. So let us assume that I have from 0 to 16. 15, sorry. 16 to 31. Okay. 2 power 6 is how much? 64. Out of 64, ROM is having 0 to 15. That means 4 address lines. The 6 lines, 4 goes there. Using the 2 address lines, we have a select logic, which goes to chip select. CS ROM. Then here also, this guy is having a 4 wires because 16 byte. And 2 goes to chip select, we call CS RAM. Okay, so if you write a program, char A, B, and A equal to 10, B equal to 20, C is equal to A plus B. Let us use int, not to confuse you. If I write a program, then what happened? I get the machine code that is stored in the ROM. The machine code is stored in the ROM. But the variables A, B, and C are stored in the RAM. A, B, and C. Is it clear? Now, I have, let us take only one. Let's take only one. 1 byte output. 1 byte output. This guy is having 8 inputs. D0 to D7. And this guy is having a signal called latch enable. And he has 8 outputs. O0 to O7. Now this is I0 to I7. Now what we are doing is, we are taking the 6 wires and give a name. This guy name is, let us assume 32. 32 full name. And that means that this guy is having 6 inputs. All the 6 are going for select logic. All the 6 wires. So if I write a program, see here, it's very important now, please note it. Int star x. X is equal to 32. Star x is equal to 1. Now let us see what is happening. I've written a very small program. I've written a very small program. Okay. Now this star x is a variable. That is this. And x is 32. I'm writing at 32, 1. So microprocessor put 32 here and is writing. So write as 1, read as 0, and data is 1. 1 means 0, 0, 0, 0, 0, 0, 0, 1. Or that is 1. That means that 0, 0, 0, 0, 0, 0, 0, 1. But let me put you a small thing here, please. One small thing. I have a logic. Address is 32. I take this signal. I also take the right signal. Okay, I also take the right signal. Let me use different colors. Take the right signal. I use the AND gate. So if the microprocessor gives address 32 and write as 1, then what will happen? This will be selected. That is what you are doing with this instruction. So please understand, one small program here is going to on here 5 volt, 0 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 volt. Now I have a 8 pin. So by changing the value, if I write here 129, 129 means 128 plus 1. 128 plus 1. So what will happen? These 8 pins, you know that it's a binary value. These 8 pins are having a value of 1, 2, 4, 8, 16, 32, 64, 128. That is a value. Now we need 129. Am I right? We need 129. So 128 plus 1. That means this become 5 volt. This become 1. See how I'm writing. See, do you understand? Both are same. See, the 1 is also 5 volt. But when I'm writing inside the microprocessor area, I'm always writing 1010. But when I'm writing outside, I mark it as a 5 volt and 0 volt. That please understand the difference. Both are same. But this also 5 volt only. But when you are writing 10, because this is controlled by the software. The software sees this as a 1 and 0. Now tell me, this board, do you understand or not? Don't understand? Let me know here. I just wanted to ask you only one question. Do you understand what is drawn in the board? Any doubt on this? Let me know. Any doubt on this? Let me know. What I write the software, this code will go here. The variable will be stored here. Now, when I put the pointer, then it's going to do this here. If you don't understand, let me know here. Since I 129, I make 1. Sorry. I'll give about 2 minutes. Watch this board. Let me know if you don't understand, let me know. This is what all about controlling motor bulb that we are going to see now. Not that we are going to see now. Is it clear? Shall I proceed further?
Yes, sir, you can proceed.
Okay, thanks. Now, let us do one thing. We know that our program is going to be in ROM. Our variables are going to be in RAM. I remove them. I don't need them. Okay. Now, I am worried about only this. I worried about only the output. So, I take only that. So, I draw this. Only the output, which has 8 output pins. This 6 goes to the logic, select logic, whose number is 32. And we connect the right, put LE. If I get 32, these 2 matches. Now these 8 pins, D0 to D7, are going here. This is I input 1 to input 7. That is outside we are connecting D0. And this is output 7, 0 to output 7. Now, when I write the program, let us take only 1 now. Let us not get confused now. Let us start writing a 1. That means that I am writing 0, 0, 0, 0, 0, 0, 0, 1. So outside when it goes 0 volt, 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 5 volt. Now I connect a bulb here. I connect a bulb here. See here, how many bulbs I connected? 8 bulbs. Now, what will happen? I give 5 volt here, only this bulb will glow. All the other bulbs will be off. Am I right? Now, the same way, if I connect a motor here, now this motor will rotate. This motor will rotate. All the other motors, let's say I connect a motor here. This motor will be off. So effectively try to understand. By writing a very small program, you can, if you make it 0 here, then that motor will be off. By writing it to the, this is software. This is software. Am I right? This is hardware. And this, you control the microprocessor, and this guy is a very important guy. The name block or select block are actually combination logic. That guy is a 1. Once that matches the address, then he generates the select as a 1 and write as a 1. This become 1. It's going. So this is where you are controlling everything. Now let us take a case. At your house, you buy a bulb. And if you have a battery, let's say you have a 9 volt battery, you connect with the 230 watts bulb. You connect a, let's say 100 watts, 230 volts bulb. Okay, but you are giving how much supply? 5 volt. Will the bulb will glow or not? No, it will not, because that bulb is, you supposed to apply 230 volts, but you are giving only 9 volts. So the bulb will not glow. Okay, current will flow, the bulb will not glow. That is called rating. Please understand, that is called rating. Every device, every electrical device that manufacturer will tell you that every electrical device will tell you what is the voltage you should apply. Okay, so I have a problem. All my bulbs are 230 volts. That is a time there's a bulb came in the market that is called LED, light emitting diode. It's actually bulb. This bulb works on 1.5 volt. Sorry, 2 volts. Sorry, 2 volts. This bulb works on 2 volts. Understand? In your house, think of a house. In your house, you have a bulb. This is a 230 volt bulb. If you apply here 400 volts, what will happen? If you apply 400 volts to this bulb, what will happen? If you apply 400 volts, what will happen? Then the bulb will get damaged. Excess current. Because of that, people normally apply only 230 volts. If there's a bulb is having 230 volts, you should apply only 230 volts. If you apply more voltage, then the bulb will get damaged. Please understand. Now, let us take a simple case. Let's take a simple case. Let me remove this slide now. Let me remove this. We'll draw it later. Think of it. I have a supply of 10 volts. I have a supply of 10 volts. I have a bulb. Please understand, this is electrical. Simple Ohm's law. V is equal to IR and P is equal to VI. Ohm power law. VI. Use only this. We will not use anything more than that. Please understand this. If I have these two, let us see that how I'm doing. I have a bulb which is 5 volt bulb. And the bulb will give you 5 watt. Understand one thing? This is a 5 volt bulb and it gives you 5 watt power. But unfortunately, I have a supply of only 10 volts. What will happen? Tell me now. How do I connect? This is 5 volt bulb. 5 volt and 5 watts. If you understand this, I remove everything, man. I remove everything. Let us try to discuss only one thing. This is very important. I have a bulb which is 5 volt, 5 watts bulb at 5 volt. But I have a battery of 10 volts. Understand? How do you connect this? If you connect like this, what will happen? This is a 5 volt bulb. You are applying 10 volt. The bulb will get damaged. The bulb will get. So this is wrong connection. This is a wrong connection. You are not supposed to do that. Now, what I have to do is I should put a resistor here. And the 10 volt should drop here 5 volt and here should be 5 volt. Understand now? So what happened? This is called voltage divider. I divide the voltage on two things. But how do you find the value of the resistor? How do you find the value of the resistor? That you have to say. Now you know that you put a resistor, it's fine. How do you find the value of the resistor? That's a trick here. The trick is they've given you one information. That means that this bulb, you connect only this bulb. If you apply here 5 volt, if you apply here 5 volt, this is 5 watt. If you give 5 volt, the bulb will give you 5 watts. So this is the relation between voltage and the wattage. 5 ohm. Perfect. Perfect. So perfect. That is, this guy is going to take about how much? 1 ampere. So now I have to pass the current of 1 ampere. Okay. That means that the current is going to be 1 ampere now. So what is the voltage to be dropped? 5 volt. B is equal to IR. B is equal to IR. Simple formula. Here I use the formula P is equal to VI. Understand? I use the formula P is equal to VI. Now P is 5 watt. 5 watts is equal to voltage is 5 volt. So into I. So I is equal to 5 watts divided by 5 volt is equal to 1 ampere. This we found out. Now, here we are doing the same thing. We have a 5 volt drop here because this guy get only 5 volt. 5 plus 5 is 10. And the current is 1 ampere. Then only the bulb will give you 5 watts. Because 1 ampere into 5 volt is 5 watts. So V is equal to IR. 5 volt is equal to 1 ampere into R. Therefore, R is equal to 5 volt divided by 1 ampere is equal to 5 ohm. So this value is 5 ohm. Now let us go to the other case. Let us go to the other case. I have a microprocessor and I have a output latch which has 8 output pins. This data goes here and this goes to the chip select, latch enable. As we discussed, the logic is 32 and go to the right signal. We'll discuss this. So we already discussed. Now, if I write a program, int star x, x is equal to 32, star x is equal to 1. All will become 0 volt. Now let us take this only this pin. This is what will be 5 volt. Now I have a bulb called LED. We put a symbol like this. That manufacturer has told you that this LED can take only 2 volt. How much? 2 volts. And this gives you the watts. How many watts? 20 milliwatts. How much? 20 milliwatts. Do you understand now? Let us take initially to assume we take 2 watts. Slowly we'll increase. Let us assume that this bulb will act. You're supposed to give the bulb 2 volts and it gives you 2 watts. Now tell me, what is the value of the resistors? That if you know how to calculate, you are passing that. Without that, every stage we are not supposed to proceed next. If you don't understand this, don't proceed. That's very important. Tell me now, what is the resistor here? Can anybody tell me? What is the value of R?
3 ohm.
How much? R is equal to how much? What is the value of R?
3.
3 ohms. You can type it, no problem. You can chat, no problem. If you're not able to voice it, you can type. So correct. How did you find 3 ohm? That you have to be very clear. How did you find 3 ohm? That's very important. This bulb is 2 watts at 2 volts. But we are applying 2 volts now. We are assuming because remaining 3 volts are getting dropped here. 2 volts we assume. Now the current is I is equal to P by V is equal to 2 watts divided by 2 volts is equal to 1 ampere. So the current is going to be 1 ampere. Now V is equal to IR. R is equal to V by I. And V is 3 volts. And I is 1 ampere. So we get here 3 ohm. So this R is equal to 3 ohm. Now let us do a small change. I change this guy to 0.2 watts. How much? 0.2 watts at 2 volts. Instead of 2 watts, this guy is going to give it 10 times less power. 0.2 watts. Okay, then what is the value of R? 0.2 watts is equal to 200 milliwatts. Both are same. Please understand. That is, if you multiply by 1000 and make a milliwatts, then it becomes 0.2 watts, 200 milliwatts. Now, what is the R, value of R? I need one answer to proceed further. I'm ready to go very slow, but please understand. You have to understand very clearly what is this here. That means that I can erase all these things. See that I don't need all of them. Let us take only one pin. Let us take only one pin. Then you take only one pin. This pin I can control through the software. I'm controlling through the software int star x. Int star x. And x is equal to 32. Star x is equal to 1. This program is making the pin as a 5 volt. Now I have a resistor and I have a LED. This LED is 0.2 watts at 2 volts. That's very important. That symbol is very important. Yeah, perfect. Somebody has given an answer. Don't type direct message, please. Put it to everyone so people can watch that the message. Otherwise, I have to tell you this answer once again. Now this is V. How much? This is 2 volts. This is 3 volts. This circuit is called voltage divider. This is a very important one. You have to remember only this. This is the most important for every embedded engineer. What is meant by voltage divider? Correct. 30 ohms is the resistor. That's correct. So, since this guy is 0.2 at 2 volts, this is the thing you have to understand. What the manufacturer is telling you that if you apply, see, this is a LED. By telling this symbol 0.2 watts at 2 volts, what they are telling you is that I will give you 2.2 watts power. 0.2 watts power if you apply 2 volts. If you apply 2 volts, then how much current he will take? He need 0.1 ampere. Because 2 into I is equal to P by V. P is 0.2 watts divided by 2 volts. It's equal to 0.1 ampere. So the current is going to be 0.1 ampere. Now the resistor is voltage is 3 volts. So V is equal to IR. R is equal to V by I. Is equal to 3 volts divided by 0.1 ampere is equal to 30 ohm. Sorry, I am blocking. It is 30 ohm. Is it clear? The trick here is this is same 0.2 watts. You can write 0.2 watts. The same thing can be written like 20 milliwatts. Both are same. Understand? We normally write here 0.1 meter is equal to 0.1 into 1000 millimeter is equal to 100 mm. Understand? 0.1 meter is equal to 100 millimeter. Here, 0.2 watts is equal to 200 milliwatts. Now I'm telling you that this guy gives you 0.02 watts at 2 volts. 0.02 watts. Then what is the value of R? What is the value of R? That has to be understood by us. Is it clear? What is the value of R? So now 0.02 watts divided by 2 volts is equal to 0.02 ampere, 0.01 ampere. The 0.01 ampere for 3 volts. So R is equal to 3 volts divided by 0.01 ampere is equal to 300 ohm. Okay, this is confusing you. Am I right? How do normally when we go to the fraction, don't get confused. This is a very simple fractions. How do you do that? Simple. This is simple maths. This is equal to 3000 millivolt. Okay. Sorry. 3 volts into 1000. Multiply by 1000 also here. If you multiply with 1000, it will become 10. 10 amperes. The ampere and voltage become ohm. 0 goes. 3 into 100 is 300. Learn to write this thing in milliampere. People don't write like this. People write here 20 milliwatts at 2 volts. That's why if you see a mobile phone, they will say that 4000 milliampere hour. They will tell you that. They always write in terms of milliamperes. That is sufficient for the electronic devices. That's why this. Here is a problem. Here is a problem. Okay. Now let us take a case. Let's take a case. I have a bulb. I have a bulb which is taking 2 volts at 2 watts. Assuming I'm using a very powerful LED which is giving you 2 watts. That means that the current I is equal to 2 watts divided by 2 volts is equal to 1 ampere. Understand? 1 ampere. Now, if I connect a resistor here, 3 volts, and the current is going to be 1 ampere. So I make a 3 ohm. Because 3 volts by 1 ampere is 3 ohm. Everything is fine. Here is a problem. Let us assume that I have a battery. I have a battery and I have a bulb. And I connect to the battery. There is something rating, like how a bulb is having a rating. 2 watts at 2 volts rating. This battery manufacturer will give a rating. This battery can give a peak current of 100 milliampere. That means 0.1 ampere. Now, how much you are drawing? If you connect this, you will draw 1 ampere. Then the battery will get damaged. You are now supposed to draw more current than what the source is giving. Like that. This latch manufacturer will tell you that my latch can supply only 10 milliampere. How much? 10 milliampere. But now what is happening? You are drawing 1 milliampere. This latch will be spoiled. This latch will be spoiled. So what we have to do is, we have to put a small amplifier. We have to put a small amplifier. There's nothing but a small transistor circuit. a transistor circuit. Forget about that. What the circuit will do, it takes the extra power supply, 5-volt power supply, and that guy will give the extra current. That guy can supply up to 1 ampere, but this guy will control. That's what you have a circuit. But generally, amplifier means analog electronics. In digital electronics, we normally don't use the word amplifier, but instead of that, we use the word called driver. We use the word called driver. Please understand the difference between amplifier and driver. Okay. Both are same. Both are same. There are another driver is there that's called software driver. Don't confuse that. That we will discuss later. What is called software drivers. Now this is a hardware driver. So the matchings are all very, very important. You should know that what is the pin's maximum voltage, maximum current. Please understand this all quite simple concept. Only 2 multiplication. Then you have a device. You have a device. What is the voltage the device need and what is the current it needs? Voltage and current. Both are important. So this is called maximum voltage current, supply current. This is a required current. If these don't match, then the device will fail. That's why you know that in your college when you do experiments and all, the devices normally burn. Okay, the devices burn because of these reasons. If these two are not matching, for example, let us assume that I have a latch which is going to give me 5 volt and 10 milliamperes. I have a motor which needs 12 volts and 1 ampere. This is, first of all, the voltage is not matching. Done. Not possible to connect. Second thing is, this guy needs 1 ampere. This guy is giving 10 milliampere. Both are not matching. But let us assume that if we give only 5 volt, this motor is a 5 volt motor. But the motor is going to take about 1 ampere. Still, it's not matching. This should be always less than this. Then you can connect directly. Now, I need to connect with a driver. This is possible for anything. You can use the microcontroller for any application, provided if you use a driver. And the driver input and the driver output, the output should match with this output. The input should match with the input. Otherwise, you cannot do anything at all. Is it clear? That is I did a small program. This program makes this pin as a 5 volt or 0 volt, but I can control any voltage. I can control even if you see that what supply voltage I'm giving. Suppose if this is the 230 volts. Yeah. It is possible. You can control by using a small microcontroller. You can control any big motor, provided you have the driver circuit. Is it clear? If it's not clear, let me know. Think for a minute. What I'm effectively saying is, try to understand what I'm trying to convey. I'm trying to convey you that your microprocessor, with the help of only address line. See here, the microprocessor is having a address line, data line, read, write. That's all. With the help of this, I have a latch. I have a outputs. Then I have a select logic. I have a select logic. Whatever matching. Then that is going to control the latch enable. Suppose I have so many devices here, motor, bulb, everything. I want to connect some more devices. Then I'll be able to connect it here. Am I right? This is one more 8. But this case select logic is different. This guy could be 32. This guy be 33. Now, if I write a star int star x is equal to 32. Star x is equal to 1. Since 32 is matching here, the 1 will come here. If I say x is equal to 33, star x is equal to 2, then this is 33. It's matching here. So this will be 0, 1, 2, because I have written 2 here. Like this, I can have n number of latches, not one or two. Each one is having a different name. Understand that. So don't ever think that this microprocessor can control only 8 pins. No, it can have n number of pins. You can connect 1000. Let us say that I put one more latch whose address is 34, another 8 pins. So 3 into 8 is 24 pins. I can control 24 motors. Clear? You can control any number of motors. You can control any number of devices. This is a beauty. This is the way your microprocessor talking to the output. Like let us compare this with your brain. Your brain is having a area called frontal lobe. Your brain is having a brain. This is full brain. Okay, this is brain. Your brain is having a frontal lobe. This guy is actually doing a process. This guy is doing the process. So this is equivalent of microprocessor. Now, this guy is having one more area called temporal lobe. This is nothing but memory. Like what we have, microprocessor plus memory. This guy also having a small memory inside. That's why when I ask you the number 4 plus 5 multiplied by 6, you do everything here, all temporary operation. Understand? So please understand this. Like that, this brain is also having so many units. This controls your hand and leg. This control your eyes. Like that. There are so many portions. They all together is called brain. So your microprocessor is not brain. The microprocessor is part of your brain. Okay, like that in your system. In your system right now, it's like this. I have microprocessor. I have a microprocessor. Then I have a ROM. I have a RAM. These three together doing a computing. Just computing. But we have one more thing called output. This is what talking to the external world. This is what talking to the external world. You cannot talk to ROM, you cannot talk to RAM. They are inside the brain. The outside is only this. Understand now? You can control any number. Don't say that only here. I can, when I say output, you can have any number of wires, n number of wires. Don't think only one. This output represents so many latches, not one latch, so many latches. Each one is having a different address, 32, 33, 34, 35. So you can control any output by writing it to the right number. That's all name. So this is what the output of your microprocessor based systems. So we have introduced ROM, we introduced RAM. RAM is used for variables. ROM is used for code, your program. And this is read only and non-volatile. This is read write but volatile. And the output is a latch. The moment you write anything, it will go on the outside and control. So you can able to control any device by having this voltage, 5 volt and 0 volt. Understand? Today, everything is controlled using this. Your entire mobile phone, all the displays, all are controlled using this output. Please understand. This is the way you are going to do that. I'll next week onwards, I'll start giving you this programming. You can start doing the programming. You can start actually, you will write the C program and control the bulbs. That's an exercise we start from next week. This week, we complete the foundation. Basic C programming and basic microprocessor based system. So next week onwards, we start controlling the bulbs and lights. Is it clear? If things are not clear, let me know. Yeah, tell me, Mohammed. Amir, tell me.
Sir, for controlling the bulb next week, like, should we buy a microprocessor? Or...
No. We told you, we have 3 methods. We first do the C programming, then we do simulation.
Okay.
I will make sure that you pass all the programming. That means that you do the your programming level is very good on the simulation. Then you can buy a board. Doesn't matter. Because if you buy a board now, you have a lot of variables. You will get confused whether your problem is the software or problem with the connection, everything. But once you test it here, you will be very thorough. That's why I always make people to do first on C programming, then do on simulation. You can do even a good projects on simulation. Okay, then if you have done it, then go to the hardware. It's a third stage. First, second, and third. You can do, you have around say time. Once you have done simulation, then when you go to the hardware, you will be really surprised. God, the same program works here. Nothing. I told you now, I've been in the industry for so long. Both are same nowadays. Don't think that these two are different. Only thing here is the connections. You use a breadboard. Sometimes there'll be a loose connections, and sometimes you do the wrong resistors. So because of that, the things will burn, those things. But your general core software is same for both to do. Okay, now let us take a small break, about 5 minutes. Then we will come back and discuss about the next important topic is input. Okay, so please understand this is only the idea. This is not the end of it. I told you, this is not the last day of the course. This is only the first 2 weeks are over now. Okay, we have a lot more time. And don't worry about that. If you don't understand, don't worry. We'll proceed further. We'll make sure that once you start doing the experiments, then come back to the theory, you will understand. There are so many methods are there to learn the things. But let's not move too much. Let us try to understand the very small output and input. Enough. Okay. I'll give you a lot of, like a C program, I'll give you a lot of exercise for these outputs. Start doing them. Don't try to be hurry. Do it very slowly. Okay, let us be back after 5 minutes.